Okay. Okay. So good. So we have the 128 bits long represented in a hexadecimal. Like I was saying, the hexadecimal is a base 16 address. So when you look at this IP version 4 address, you have 32 bits long address, and this is a class C IP version 4 address. And the reason why it's a class C, when we move forward, you get to understand. Now, when you look at the 128 bits long address, it is also separated by semicolons, right? And all these zeros can be compressed to have a simpler format. Now, networked equipment addressing. Now, host devices need both addresses to communicate on the network. The host devices need both the MAC address, and then they need the IP addresses as well to be able to communicate. So when you look at LAN 1, right? This is a local area network 1. This laptop here has a MAC address, and the MAC address is simply an address that is burned in the buffer of the networking card, and the first 6 address represents the manufacturer, and the last 6 address represents the host itself. So any device that joins a network, first the MAC address is displayed, and it is used to identify that device. So in unified threat management or networking security, we are able to do what we call MAC filtering. The MAC filtering is able to identify, or we can assign uh, uh, a particular access to a particular uh, MAC address of a particular device because it identifies it. So if it is only that device that comes on the network should give it an access. If another person brings another computer and it has a different MAC address, that co computer must not be allowed specific services like internet service, like being able to be on the network and all that. And it's one good way of being able to identify devices as in the device itself. And then we have internal protocol addresses, which are logical addresses that are also used to augment the MAC addresses to be able to identify the hosts on the network, and then for the sender to know where the information is coming from or the data is coming from, and for the recipient to know who is sending, and for the sender to know who has to receive. Now, like I told you, or like we discussed in first year, I told you that when you come to school, you have your name and then you have your index number. Both numbers can be used. When you go to the office, when you mention your name, they can use your name to retrieve your index number, and they can use your index number to retrieve your name and all information about you. And sometimes your name and your house number can also be the same. It's both like the MAC address and the IP address. Both of them come together to give an exact location of you. So that is how it works. So you realize that this has its own information, that is .8, and this one is all its own information. And this is on a different network, 192.168.200.8, and this is also on another network, 192.168.100.8. They are two different LANs. Like you are here or you are in the KTU local area network and somebody is also in Ghana Telecom University network. All of them, their IPs are on different networks, but there can be a communication between the two of you, like we are communicating right now within different networks at different areas. So an IP version 4 address is composed in two parts. We have the network portion and then the host portion. And then the second part, the first part identifies the network, and then the second part identifies the host. So you have an IP address of 192.168.200.8. Which part is the network part and which part is the host part? Now, this is a Class C IP, and the Class C IP is denoted by network, network, network host. It means that three portions are taken by the network, which are these ones, and then the last portion, which is denoted for the host. So this 192.168, this 192.168, this 192.168.200.8, which is a Class E address, has this 192.168.200 as the network portion, and this one as the host portion. And by now, you should know how to convert decimals to binary. So the meaning of this is what is showing in binary. And this one is showing the host portion because it's a Class C. And normally the host portions are zeros. Now, the subnet mask is used to resolve the IP address to be able to determine which network address this IP address is coming from. So the 200.8 is an IP address because it has been assigned. And which network address did we assign the 200 the dot 8? The subnet mask for a Class C is 255.255.255.0, which is denoted in binary as this. And the 0 here is what we are seeing here. Now, we want to find the network address for this Class C IP address. What you do is you do the ANDing process. The ANDing process is simply resolving the subnet mask with the IP address in a binary form. And in multiplication in binary, when you multiply 1 by 1, it should give you 1. But when you multiply 0 by 1, it should give you 0, or 1 by 0. So normally, when we do the AND gate and we do the truth set, you realize that 1 resolved to 0 will give you 0. 0 resolved to 1 will give you 1. 1 resolved to 1 will give you 1. And 1 resolved to 0 will give you 0. And it will give you the truth set. Now, in the same way, you are multiplying this by this. And when you do all the multiplications for both the network portion and the host portions, this is what you get. 1 times 1 will give you 1. 1 by 0 will give you 0. 0 by 1, 1 by 0 will give you 0. So in all this, when you translate them back into binary, into decimals, this is what you get: 192.168.200.0. And this 192.168.200.0 is the network address from which this particular address have been assigned 8. So this address is unusable, but out of this address, a computer has been given a number 8. So this particular computer number 8 IP address is generated from this network address. That's the meaning. Good. Now, there are two rules to reduce the number of digits as is represented in IP version 6 hexadecimal address. Now, the first rule is to omit all zeros or leading zeros. Omit leading zeros. And then the rule 2 is to omit all zero segments. Now, you have a fully expanded IP version 6 address. This is it. Right? Now, when you have an address like this, right, there are no leading zeros. When you have an address like this, you have to remove all the leading zeros. And when you remove all the leading zeros, this is how it's going to look like. And then when they are compressed, this is how it looks like. So this long address can be compressed to look this way. And I think on a separate time when you have to do a course in CCNA 3 and 4, I'll painstakingly go through IP version 6, and you know what really goes into IP version 6 for your understanding. Because what most of the computers now are using IP version 6, and you have to know how you have been able to do the conversion in IP version 4, and how you are able to play and rummage around IP version 4, and you are able to do your networking, subnetting, supernetting, and all that in IP version 4. The same way IP version 6 also has its principles, and you need to understand them thoroughly to be able to play around them. And then today's networker should be well versed in IP version 6. And that is what I expected that you should have done in data communications and networking in second year, so that after learning IP version 4 in second year, you do in your courses, you do IP version 6, and so that you become well versed in it. I don't know whether whoever taught you did that, but if you want to go through that and learn that, you need to come for a special class. Good. And then, so in the same principle, we have the same principle of compressing a longer IP version 6 address. Now we want to talk about transport layer and the two protocols that govern the layer transportation are the TCP, which is the transmission control protocol, and then the user datagram protocol, which is the UDP. Now, in the networking medium, when it gets to the transport layer, depending on what kind of information or data is being transported, will automatically determine which protocol that has to take control. Now, if it is video, right, and voice, or if it's a multimedia application, if it is being downloaded or it is being uploaded, one of them will have to take control. Especially the TCP requires an acknowledgement when data is being transmitted. It is more reliable because it provides acknowledgements. Now, when data is sent or transported using this protocol, and if any part of the data is lost, it resends that part that is lost, and then it delivers data in a sequenced order. So you can liken it to the post again and say that when you go to the post, they have different types of the postal systems. We have the DHL or the EMS, which requires a lot of documentations. They are more reliable because in this part of the world, when you want to send a very delicate document, you say go and use DHL. Why? Because it's more reliable. Because if the information that is even being sent gets lost, they will have to pay for it and pay in interest. And then they have to deliver data, or they have to deliver the data in a sequenced order, which has to do with timing and delivery. Now, in the same postal system, you realize that there is high overheads because because of the information and how reliable they want to make the information. The EMS or the DHL is more expensive. But then, that same information, you can still go to the post, get a stamp, put on your envelope, and then you send the information. the probability that that information will reach the person is also high. When we were all young, we were sending letters and the letters were reaching. But nothing will show that the person has gotten your letter until that person has replied. Now, with the EMS or the DHL, when the letter reaches, it is a registered letter. When it reaches the destination, anybody who the letter is taken to will have to sign. The information about the person who received will have to be taken. And the owner will be made aware that the letter has reached its destination. But for the normal post, when the letter goes, it has gone. It goes to lie in the box. And then the person will go and open his box and pick it. Truly, most of the time, the letters also reach their destination, but it is not costly. It has low overheads. It does not require any acknowledgement because it will not show you that the letter has reached. And then it does not resend data and it delivers data as it arrives. So in electronic communication, we have the UDP, that is like the normal letter, which also sends information from source to destination. And when it reaches, it has reached. It has low overhead. So when you send a digital when you send a WhatsApp, you see that when it reaches the person, it clicks double that it has reached. As soon as the person reads the letter, then the blue comes for you to know that that person has seen the information. That is the kind of acknowledgement we are talking about, and we say that that's a TCP arrangement. When you send an email, as soon as the mail reaches the person, it tells you message sent. If it doesn't go, it will tell you mailer demon message uh, was not sent. These are all TCP acknowledgements for you to know that the information that you are sending has either reached, and it's a more reliable form of transmission. But then the UDP, when the information is sent, it does not show any acknowledgement, and it has its own advantage because when it is a multimedia application that is being sent and part of the video is sent, uh, if it begins to give acknowledgement, message sent, message not sent, message sent, if you are watching the video, you cannot watch it because of the too much acknowledgement. So for the transport layer, the UDP and the TCP are the rules of transmission depending on what kind of data is being sent, what kind of information is being sent, and then one protocol takes over to make sure that this information reaches its destination. Now, the TCP and UDP use what we call source destination ports and numbers to keep track of applications and conversation. So, at the TCP port 20 takes care of file transfer protocol for data, and then and then if you can hear me, just type yes. If you can hear me, just type yes. Okay, that's good. That's good. Some calls are coming through and disturbing my network. Okay, so the TCP uses port numbers, and it uses the port numbers to track which kind of applications are using it. So for file transfer, it uses port 21. For secure shell, which we have discussed, uses port 22. For telnet, uses port 23. For domain name service, uses port 53, and all that as it moves on. So every application in the TCP IP settings uses a particular port number for data communication. So this is it for chapter 7, and we have a summary of chapter 7 of what we have discussed. Thank you. We begin uh, chapter 8 right away. So you stay tuned. If you have any questions, please put the question in uh, the typing area or the chat area so that I can look at it and then answer it. Thank you so much.